In this short video, we're going to be learning about the logarithmic function. To start off, we're going to be first graphing the exponential function y equals 2 to the power of x. So first, I'm going to start off with a table of values. Now I'm going to plot these points on a graph, and I already done this ahead of time on Desmos. So right here, this is a graph of y equals 2 to the power of x, and now I'm going to list some properties of this graph. So first we're going to look at the domain, and the domain of this graph is XCR, so x can be any real number. So as you can see on the graph, there are no restrictions on the x, and it goes on forever and ever on both sides. So next we have the range, and the range is YER. Y is any real number. However, y is greater than 0. For the range, all the y values have to be greater than 0. So then that's why we have YER, y is greater than 0. Next we have the y-intercept. So by looking at the graph, we can see that it intersects y-axis at 0 and 1, so then y equals 1. And then finally, there's a horizontal asymptote at y equals 0, so as x reaches negative infinity, it gets really close to 0, but it never hits it. Next, we're going to look at the inverse of an exponential function. So you would write the inverse as x equals 2 to the power of y. And then after, in order to find the inverse, we would usually isolate for y. But since y is an exponent, this is really hard. So then mathematicians made a new notation. And this new notation is y equals log base x. Okay, so both of these functions, the new notation and then the inverse of the exponential function, are equivalent. There's just two different ways of writing it. And the second function is obviously called the logarithm function. Okay, so next I'm going to show you how to write the general form for the logarithm function. So it's y equals log base x. Next, I'm gonna draw a graph for this equation, y equals log base 2x, but first I have to make a new table of values. However, since it is basically the inverse of an exponential function, I just interchange the x and y values. After I plotted the points from the table of values, this is a graph I got, which was made using Desmos. The inverse graph is basically a reflection of the exponential function graph. Next, we're going to look at some of the properties that I came up with looking at this graph. So the domain of this function is XCR. X is any real number, but x is greater than 0, as you can see by looking at the graph. For range, we have y is an element of any real number, so there's no restriction placed on the range. The x-intercept is at 1, 0, so the graph touches the x-axis at 1 and 0, those points. And then we have our vertical asymptote, which is y equals 0. The graph gets really close to 0, but it never touches it. And an important thing to notice is that everything basically got flipped. In the other graph, we had a y-intercept. Here we have x, and then other one we had horizontal asymptote, and here we had a vertical one. Okay, so basically to sum everything up, log is basically taking the inverse of an exponential function and rewriting it in a new notation. Next, we're going to look at writing the inverse of an exponential function as a logarithmic function. So basically, there's a general form we follow. So first, we're gonna be writing y equals b to the power of x. Next, we then switch the x and y values. So it would be x equals b to the power of y, and then we can write y equals log base x. And then this is the process we are always going to follow when converting the inverse of an exponential as a logarithm. In the first example we're going to do y equals 4 to the power of x. So first step is to interchange the x and y values. So we have x equals 4 to the power of y, and then we're going to write as a logarithm. So y equals log 4 base x. Next, we have another example with a fraction y equals 1 over 3 to the power of x. We interchange the x and y, so then we have x equals 1 over 3 to the power of y. And then lastly, it looks kind of weird, so we're gonna write it as a log. So y equals log base 1 over 3 y. Lastly, we're gonna look at evaluating a logarithm function. So we have log 1 over 100. So first step is to put an invisible y in front of the equation just to make it easier. And then next we're gonna put a 10 there, because whenever there is no base, you just have to assume that the base is of 10. So now that it's in this format, we're going to put it in the exponential format, so base to the power of y. So in this case, 10 to the power of y equals 1 over 100. And now in order to solve for y, we need to make sure that both of the bases are the same. So 10 to the power of y equals 10 to the power of negative 2. And now that both of the bases are the same, we can get rid of the bases and just solve. So y equals negative 2. So there's a general form you follow. So it's y equals log base x, and then you convert this to base to the power of y equals x, and then you would always use this form to solve these kind of equations. That's it for this video, and in conclusion, a logarithm is basically taking the inverse of an exponential function and rewriting it in a new notation.